Afternoon, everybody. Thank you for joining us on today's Adding Value program. We've got a really busy schedule ahead of us this afternoon. So we've got some great presenters from across the automation industry. We're really lucky to be so well attended, and we're really lucky with some of the people that we have actually presenting for us today. So we're going to hear about some new products, we're going to hear about some new software, some innovations in terms of technology. Each of the presentations is going to be kept to about 20 minutes long, and then we're going to have time after each presentation as well for some questions and answers. So anybody with any questions, please put them into the Q&A section, and then what we'll do is we'll pick them up at the end of each presentation as well. So all the questions will be answered, and we'll do that at the end of each presentation. Next up, everyone, we have Andy Glover from WEG, who is going to be covering the W32 sync motor and IE4 and beyond. So some super high efficiency motors. Are you there, Andy?
I'm here.
Oh,
raring to go.
Perfect. I keep panicking that I'm going to say that at some point, and then I'm just going to get a load of silence back. I haven't actually thought of a plan yet of what I do if someone doesn't answer.
Okay, so if you can see my screen, okay?
Yeah, perfect.
Super. Okay, so good afternoon, everybody. My name is Andy Glover. I'm the Product and Business Development Manager for Low Voltage Motors here at WEG UK. I've been here for the past 23 years, sort of with a variety of different sort of disciplines within my time. Our presentation today is titled W23 Sync Plus Beyond IE4. I just would say I have been having a few IT issues today, so if my screen crashes and I disappear, it's not because I've sort of taken flight from everybody. I've just had to restart and rejoin. It's something I've got as an ongoing problem at the moment. So hopefully, fingers crossed, everything will be okay. So with this presentation, what I'd like to do is share with you an overview of what we see. We obviously we all want to sell our products, but equally we need to be sort of respectful that there are other people out in the market, and we need to talk about what is available to you as users. So with our presentation, we'd like to share with you an overview of, let's say, the main commercially available motor solutions, which offer ultra premium efficiency. So those efficiencies beyond IE4. And obviously, in particular, we want to highlight some of the features and benefits of WEG's W23 Sync Plus platform. We want to give you a few energy saving examples. And we're just going to touch on what we call our C Plus tool, which is can be utilised to evaluate energy and emission saving potential if you use these higher efficiency products. So before we get sort of started, I just wanted to just give you a quick reminder of where we stand as far as legislation is concerned. So as of today, in UK and Europe, the minimum energy performance of motors and including there as VSDs, but a different level, is defined in this Commission Regulation 1781, which was published in October 2019. There was a small amendment in February 2021, and this is adopted into UK legislation through the Statutory Instrument 2617. And the initial implementation of these regulations took place on the 1st of July 2021. The key changes that were introduced in the first stage of the regulation was the addition of 8-pole motors. IE2 became the minimum for small powers from 0.12 to under 0.75 kilowatts. IE3 was extended up to a megawatt, which previously was 375 kilowatts. Hazardous area machines came into the regulation scope for the first time, with exception to the increased safety EXEB machines. Brake motors came into the equation, as did what we call TEAO motors, so motors that sit inside axial fans. And there was some of you may remember, we used to have this exception where we could sort of supply an IE2 machine provided it was used with a VSD. That loophole, if you want to call it, was removed. So as of July 2023, the second stage of the regulation was implemented. The primary changes was that was a requirement for motors of 75 to 200 kilowatts with 2, 4, or 6 poles to meet the minimum efficiency level of IE4. Alongside this, single phase came into scope at IE2, and the EXEB increased safety motors that I spoke on the previous slide. IE4 doesn't apply to hazardous area machines, although a number of manufacturers, and including ourselves, can provide IE4 EX motors for use in zones 1 and 2. Some machines do sit outside of the scope of the legislation, and they, as a consequence, they can still bear the CE or the UKCA markings. But any product that sits within the scope has to meet these efficiency levels, otherwise you cannot apply CE or UKCA markings. So what are the most common electric motor solutions to offer, let's say, IE5 and beyond? So we all know the main workhorse of industry for decades is the induction motor, available with varying efficiency levels depending on legislation. Induction motors can be found on countless applications. It's the most common machine used in industry today. Advantages, typically they are interchangeable with low efficiency machines. They're suitable for use with or without a VSD. They're robust, they're easy to repair and maintain. They're widely available on the market. Simple to control with standard VSDs. Power factor is sort of industry norm. Safe in hazardous areas, and generally a relatively low capital cost. The disadvantages, shall we say, is if we're talking above IE4, is there's a very limited range of power ratings that can be available to achieve IE5. Typically, you're looking at higher powers, perhaps above 75 kilowatts. The efficiency on induction machines is always lower at reduced speeds. On IE5 induction, you have very high locked rotor current. Could be typically 10 times full load current. If you're using a product for constant torque applications, it's very often derating to consider and forced ventilation. And by virtue of being an induction machine, you also get heat generation in the rotor. Another technology which you've maybe heard of is the sinkless reluctance motor, the SynRM. WEG doesn't produce a true SynRM as some of our competitors do. Instead, we offer a hybrid solution, which we'll touch on in a few minutes. As the name implies, sinkless, the motor runs at synchronous speed, so its speed doesn't vary with load. Obviously, unless you change the speed of changing of the VSD, but the full load speed stays synchronous. And if you compare with the induction machine, some of the advantages and disadvantages would be that, again, advantages, they are interchangeable with induction machines. In some cases, maybe there's reduced frames. They're still robust, easy to maintain. They do have better efficiencies at slower speeds compared with induction machines. They don't have rotor losses. They don't incorporate magnets, and they'll have lower rotor and bearing temperatures. So some of the disadvantages is that if it's perceived as a disadvantage, they can't be run on sinusoidal supplies. They need a VSD to operate. The power factor is generally low. The running current is typically high, can be as much as 40% higher than an induction motor. And it's typical that the supplier of the motor will insist on supplying a matched package. And the net result is very often you'll end up with a higher cost for the motor and drive package if it's coming from one supplier, mitigating these issues with the power factor and the efficiency. So alongside SynRM, we would have the other main synchronous motor technology, which would be the permanent magnet motor. So PM machines can offer very often a reduced frame size and consequently weight compared with induction machines. For IE5, we'd look to try and make sure that we offered the same frame size for interchangeability. They're still built on the same robust construction as induction machines. They offer much higher efficiency across the whole speed range. They have lower running currents, higher power factors. Constant torque can be offered across a much wider speed range than induction machines. Forced ventilation isn't required, so that's immediately an energy saving if you don't need to use a forced vent. They're compatible with many standard VSDs. A lot of manufacturers' VSDs do incorporate PM control. And again, similar to the SynRM, they don't have dual losses in the rotor, so we have lower bearing temperatures and extended relubrication intervals. Like the SynRM, they still need a VSD with which to operate. They do require some specialist assembly and disassembly, and of course there's still the recycling to consider at the end with the magnets. And there's a slightly higher initial cost due to the fact that they use rare earth magnets. So aligning with its own sort of environmental and sustainability and government targets and net zero targets, and WEG is one of the largest sort of global manufacturers of energy-related products. We've developed what we call the W23 Sync Plus platform. So W23 Sync Plus was developed to provide user with the best performance across all operating speeds. And as I said in the previous slide, we've entered the market to offer these in the same frame size as the equivalent induction, so that there's the simple interchangeability. W23 Sync Plus is the widest power range on the market today. Our power range extends up to 1.2 megawatts, and they're offered at IE5 efficiency level, and we have in parallel what we would call our Sync Plus Ultra, which we'll talk about in a few minutes, which meets theoretical IE6 efficiency levels. Just say, considering the advantages and the disadvantages that we see with CNRM and even with PM, the W23 Think Plus was developed with what we call a multi-platform approach. So for motors up to 55 kilowatts, what we're doing is we're using a ferrite assisted CNRM machine. So effectively it's a synchronous reluctance machine, but we use ferrite magnets in the rotor to improve the power factor and reduce the current, and consequently that can reduce the size of the VSD. For 75 kilowatts and above, we've essentially redesigned our previous permanent magnet line, and that's why we've now extended the power rating up to 1.2 megawatts. Obviously, the use of ferrite instead of rare earth metals offers significant benefits in terms of recyclability, material cost, and obviously availability. And whilst rare earth magnets are more susceptible to price fluctuation and availability, because we're obviously very reliant on Asian suppliers, the volumes tend to be much lower than for small motors. Inventory is easier to manage more easily, and we also benefit from the fact that we do have manufacturing facilities over in China, which can help us significantly as well. So as you highlighted, the CNRM motor has some disadvantages in regards to power factor, current, and efficiency at lower speeds. So our topology for the machines up to 55 kilowatts is to use the same rotor geometry as a CNRM machine, but with the introduction of magnets in the rotor. So this helps us to improve the power factor and to reduce the current. So if we see this example, the efficiency of a CNRM is significantly better than an induction machine across its speed range, but it's lower than the W23 Sync Plus hybrid design. And conversely, the power factor of the CNRM is much lower than that of an induction machine, and even more so against the hybrid ferrite CNRM. So both the W23 Sync Plus hybrid and the PM designs, we use lower loss electrical steels in the laminations. We have an optimized electrical design, and with coupled with the absence of rotor losses, which we have with the synchronous machines, energy savings come up to 40% could be achieved if we were comparing IE5 against IE3. So here we've got a couple of typical efficiency curves where we compare induction, the ferrite assisted, and the PM, considering variable and constant torque loads. Obviously, by far and away, the main or the largest energy consumers are going to be pumps and fans, and obviously they generally operate with parabolic loads. So typically at lower speeds, the absorbed power demanded by the pump will be significantly lower than the nominal motor rating. Under these conditions, induction motors do present a significant decrease in efficiency because some of their losses remain constant irrespective of the load. Conversely, the PM and the ferrite assisted CNRM have much lower losses than induction machines. So even at lower speeds, their efficiencies don't reduce dramatically. So as a consequence, if a pump system operated with an induction machine, the VSD can already have significant energy savings. The savings will be even higher if we're using PM or ferrite assisted CNRM. If we take the previous example of the 15 kilowatt, 1500 RPM machine, if we were running this machine at full load power and speed, IE3 induction machine would be around about 92% efficient. At 70% speed, 75% speed and load would reduce to about 91.2, and at 50% speed and load would reduce to about 89.6. We compare the synchronous reluctance ferrite assisted and PM designs. We see that the full load efficiency is a shade over 95%, but more importantly, at the partial load conditions, the efficiencies are virtually unchanged, only by about 0.5%. And just as an example here, we have a 55 kilowatt machine working for just 2,400 hours per year, and And this is prior to the obviously exponential increases we've seen in energy costs. We can see that selecting a Sync Plus machine IE5 instead of IE5 could realise annual energy saving of about £424 for an additional investment of £700. So at 13 pence per kilowatt hour, the anticipated return on this investment would be under 2 years, which I think in most cases would be perceived as being acceptable. We then consider the much higher cost of energy as it is today. So say in this example, 23 pence per kilowatt hour, we'd see that same £700 additional investment could be realised in under a year. Obviously, aside from the energy saving potential, W23 Sync Plus motors offer some key benefits compared to induction machines. Particularly, they have lower material content, long service life, extended bearing life because of the lower operating temperatures, don't require forced ventilation on constant torque applications, and low noise levels. As far as the speed control of Sync Plus machines, as I said earlier, there's obviously a number of other drive manufacturers' products may be suitable to operate with these machines. The WEG's automation division is offering what we call our CFW 500 and our CFW 900 families of VSDs. As I said, other VSDs from other manufacturers may be capable of controlling these motors, but we would highlight that within our drive, we do have an optimized firmware to suit the machines. One particular characteristic is what we call the MTPA. It's a mean maximum torque per amp. It's basically a function which continuously searches for the optimum operating point where the motor generates the necessary torque using the lowest current and thus minimizing energy consumption. And of course, being as the product, the motor and the drive comes from the same manufacturer, origin to startup is very, very simple. And alongside that, we offer an extended warranty of 3 years. So our presentation title was referred to as IE4 and beyond. And thus far, we've focused mainly on the W23 Sync Plus IE5. So further efficiency savings can be achieved with the selection of what we call W23 Sync Plus Ultra. So what we've essentially done is we've taken the efficiency values from the IEC standard 60034-30-2 and applied the same sort of criteria of 20% lower losses to achieve a theoretical IE6 range. We offer the same power ratings on the IE6 as we do on the IE5, so we have the same breadth of ratings and speeds for both. And I think it's also important to note that efficiency savings are achievable on all motors. Whilst it is very often the big ticket, the large power motors which are considered as the obvious target for energy saving, small power motors shouldn't be discounted, as the gain between each efficiency class is much greater. So by ways of providing an actual example of the benefits associated with W23 Sync Plus against induction machines, we've got a case study here from a pet food manufacturer in the UK. So this manufacturer has 7 250 kilowatt IE2 machines, WEG brand, installed on his plant. It's the largest consumer on the site, and it runs 24/7. They're already controlled by VSD due to the application, and as such, those motors were equipped with forced ventilation. So an interchangeable IE5 PM machine was installed to prove the concept, and because it was a PM machine, we didn't require any forced ventilation. So immediately there was at least a 2.2 kilowatt saving just by removing the forced vent fan as well as space. The energy consumption with the IE2 machines was 98 kilowatt hours for the IE2, and that reduced to 88.8 for the IE5, and that resulted in an energy reduction to the client of 9.42% against his target of 5%. And that's also an annual saving on that machine, on one machine, of £12,490. Return on investment, including the installation costs, was 25 months, and the target for the site was 5 years. So we came in well below what the customer was actually looking to achieve. And projected savings for the 7 motors would be over £87,000 a year. So as a consequence of these results, the client will be is the remaining 6 units will be upgraded, but in this case they'll be upgrading to the Sync Plus Ultra IE6 as opposed to IE5. For classified environments, the Sync Plus is also certified for use in zones 1 and 2, so EXEB, EXEC machines for gas and vapours, and for zones 21 and 22 for EXTB, EXT machines for combustible dusts. And for those of you guys who maybe have medium voltage motors on your site, the Sync Plus design is soon to be expanded for electrical supplies up to 6,600 volts. So, as you see, Sync Plus affords users the opportunity to reduce energy costs when compared with induction motors. And in parallel, to reduce carbon emissions. So we consider that the downstream phase of a motor typically represents as much as 98% of its overall emissions. We can see with these 3 examples that over a typical life of, say, 25 years, selecting an IE3 instead of an IE5 instead of IE3 can offer CO2 reductions of over 16 tonnes of CO2 for a 5.5 kilowatt machine, over 50 tonnes of CO2 for a 30 kilowatt machine, and over 95 tonnes of CO2 for a 75 kilowatt. So you guys with your net zero targets, these are certainly things very much to take into consideration. So to aid customers evaluate let's say the feasibility of upgrading old motors for higher efficiency designs or selecting higher efficient designs, WEG's developed what we call our C Plus tool. C Plus, it's freely accessible on our main website, and that's www.weg.net. So here comparisons can be made to replace a running motor, a failed motor, a new installation, as well as a gearbox and drive replacement. Registration enables access to what we call the projects area of the tool, where more detailed calculations can be made. The default criteria can be set in the control panel, where you can set average energy cost, operating hours, and which motor lines you would like to make the comparisons against. And by selecting the country of use, the tool automatically also applies the appropriate carbon emission factor, because that obviously changes from country to country depending on how their energy is actually generated. So the basic version of C Plus enables you to make the initial assessment on energy and what savings might be realised by selecting a high efficiency machine. You select your calculation options, the equipment data, the running hours, your energy costs, and details of the existing machine. You select the new motor that you're intending to replace it with, or you would like to select, add its cost as well, and the VSD if applicable. And then once this step has been completed, the results on the right hand side will be displayed. So we'll see the savings in pounds and kilowatt hours. We'll see the reduction in tonnes of CO2. We'll see what your investment needs to be, what your return investment will be, and what your projected savings could be over a 10-year period. And once the data's been inputted, has been complete, you can generate a report and download in PDF, or obviously use the QR code that's within the report as well. We're also increasingly asked by customers to provide emissions data for our products. I think it's quite a topical thing now. We've developed in parallel what we call our Eco Hub tool, so we can calculate the carbon footprint of the motor. Presently, it's only an internal team accessible by WEG internal teams, but the information can be provided upon request for customers, and I'm sure in future will be something we can release to the market. Calculations here are made based on the bill of material and the production site that it's produced, and provides data on raw materials, the process parameters, and the local emission factor. So, as I mentioned, the tool provides the results considering the emissions factor for the intended country of use. Reports can be generated covering the upstream, just the upstream core, and the downstream. And we use 3 calculation methodologies. So either the GHG protocol, ISO 14067, or PAS 2050. Essentially, they do the same thing, but each of them have different levels of content. as with C++, the report can be generated and submitted to the client. I'm just going to finish with one thing, which we call. Sorry, just going to finish with what we call with ECUB. Also enables us to do what we call avoided emissions by not selecting the most efficient motor. So here, if we select the kilowatt rating, the operating hours, and the required lifetime of the chosen motor, so let's say in this case it's IE3, the avoided emission report can indicate to the annual emissions, the total emissions over its lifetime, and the emission savings in tonnes of CO2, and as a percentage, which could be avoided were a more efficient machine to be considered. So essentially what we're saying here is if a customer determines what he wants to select, he could actually see what additional what emissions could be avoided had he selected a more efficient machine. So in summary, we can see that selecting motors from the C+ platform offers, we think, a wealth of benefits over and above induction machines and true CNRM. And we hope that energy saving and carbon emission reduction potential will at least prompt you guys to considering the selection of higher efficiency technologies in the future. So thank you very much for listening. And I don't know if there's any questions.
Thanks, Andy. That's been really, really good. Really informative again. It's amazing the difference, just selecting between a different motor can make cost savings wise and things like that, especially when you're having to factor in CO2 costs and things. Again, yeah. Again, so for everybody that's joined us more recently, the links to these are going to be provided in the videos as well. So links to the website there where you can use the tools will be provided. And again, if we're supplying you with motors, we can provide that information on your behalf, so we can work that out for you as well. But yeah, fantastic presentation, Andy. Thank you very much. Has anybody got any further questions on this one? No news is good news, Andy. I think that's.
Well, obviously, if there are any queries that you think about afterwards, then like I say, bang them into to the guys at Quantum, and we'll do our utmost to get back with a prompt response for you.
Perfect. Thank you very much. That's great.
Not a problem. Not a trouble at all. Thanks very much.
Thank you.